What going on? What is ULC? Good night, everybody. Attention, villagers. We inside. Lal. What up, what up, what up, what up, what up? Ready to find your ex, boy. Guys, non-copyright songs. Yeah, problem on Gerard. Gerard, I don't know about them things, man. Leave him, leave him. Allow him, allow him. Allow him. We shall allow him. Already, I don't expect a big turnout because men just only want to study the night before exams, so I will still jump out the night before exams and give a little advice and thing. You don't know. So I see we could start there. Come back here. Put that so, put that there. Then jump across here. But I just open my playlist, start to play. That's it. Right, so I think we could start there. No? I think we could start there. Thank you. Can you take that away, please? Everybody know here your bench. Sorry. These paper ones look hard. Paper ones is cake, boy. See how easy that AddMaths paper come? Well, let's see how easy that AddMaths paper come. Easy like peasy, I guess. Right. Let me do something there, right? So instructions important. Paper consists of 45 items. You have 90 minutes to answer them. In addition to this test booklet, you should have an answer booklet. Each item in this test has 4 suggested answers, A, B, C, D, and E. A, B, C, and D. Read each item you are about to answer and decide which choice is best. On your answer sheet, find the numbers corresponding to the item. Them thing is basic. Best answer for to 0. You know what would be real interesting? If they actually bring a question that is the sample item with the correct answer. That would be real interesting. If you want to change your answer, erase it completely and fill in your new choice. When you're told to begin, calculators and mathematical tables are not allowed. What? What? Something wrong with it. Yeah. Alright, don't do that. You could use calculators in paper 1. Stream last night was real good. Yeah, I know. You gotta tell me that. I know that stream was real good, boy. Top tier. Alright, let me start. Now, at any point in time, if you have a question, you want me to explain back something and did in a question, tell me, so do over number 3, do over number 2, because by the time all you see in a solution, I will physically already be in probably 2 or 3 questions in front of it. Right? Paper 1 repeats a lot. Like questions repeat a lot, and you will see a lot of questions being repeated. Now the specimen paper is the hardest paper because it is the specimen paper. It should be a standard for that new structure, those new topics for the year. So the questions that come are going to be generally more challenging. 2012, 13, 14, 15 going up the road, you'll see how easy it is. 2018 there was another specimen paper, so that specimen paper is going to be a little bit challenging as well. And 2019, 2020, and finally 2021. Alright, so there we go. Given that is that, and that is a factor, then k is equal to, alright, so I am going to show working in the benefit of you guys, but there are a lot of shortcuts we can take to do these questions. There we go. F of x over, they say x minus 2, that is f of 2, and they say that f of 2 is a factor, so f of 2 is 0. So I have 2 cubed plus 2 into 2 squared minus 5 into 2 plus k is equal to 0. Everything had to go on the right, so there's 8 plus 8 minus 10 plus k, 16 minus 10 is 6. Send it across. K will be minus 6. A. That is equal to, all right, so we have a little expansion. That is AB plus AC minus AB minus AC. So AC minus AC. So AB minus AB. AB and AC. And then, oh, BC, sorry. Last one is BC, my bad. Minus BC. So AB minus AB. C is common here. So it's C into A minus B. C into A minus B. Alright, so the value of this is, now the summation sign can be used to form an arithmetic progression. If I recall, we might just do one paper every night, fellas. So I'll just change the title of the video. If we're doing working like this, one paper per night, we'll have enough time. This summation sign means to add up. The number below A tells me where I'm starting, and the number on top B tells me where I'm stopping. So, for example, if I have the summation from I is equal to 1 to, let me say, 3 of 2I. I is my variable. So these limits, the top limit and the bottom limit, it tells me where I'm starting and where I'm stopping with respect to I. So I'll add up. Now, there are integers. The summation sign works with integers. So you'll go I is 1, then I is 2, then I is 3, then I is 4, then I is 5, 6, 7, 8, 9, 10, until they have the cutoff point, which is the number on top. In this case, the number is 3. So I'll substitute I is equal to 1, then I is equal to 2, then I is equal to 3. So I'll have 2 into 1, then I'll have 2 into 2, then I'll have 2 into 3. And the summation sign means I'm adding up all of those terms. So this becomes 2 plus 4 plus 6, that is what? 12. So in this case here, I have the summation of R is equal to 1 to 20 of 3R minus 1. This means I'll substitute R is 1, then 2, then 3, then 4, all the way up to 20 to form an arithmetic progression. Like I said, sigma, this operation is called sigma. Sigma forms an arithmetic progression. So this here, if I were to expand it out, I would have 3 into 1 minus 1 plus, that's my first term, 3 into 2 minus 1, that's my second term, plus 3 into 3 minus 1, that's my third term, and all the way, I'll keep substituting until I get 3 into 20 minus 1. That is my last term. Now in APs, we have two formulas that we can use. This question here asks us to calculate what the sum of all of these terms are, which is an AP. We have two formulas we can use to calculate the sum of n terms in an AP. Sorry. S sub n is n over 2 into 2a plus n minus 1 multiplied by d. Or we'll use both formulas. S sub n is n over 2 into a plus l, where a is my last term, L is, a is my first term, and L is my last term. So I'll use the first formula. Now I can actually put numbers for this arithmetic progression. So from here, I will get 3 into 1 is 3, and 3 minus 1 is 2, plus 6 minus 1 is 5, plus 9 minus 1 is 8, plus so on and so forth. Now you can see that this is an AP with common difference of 3. So in this one here, A is 2, D is 3, and I want to calculate the sum of all of the terms. All the terms in this AP If the terms start at 1 and end at 20, I'll have 20 terms. I'll have the first term, second term, third term, fourth term, fifth term, all the way up to the 20th term. Now, in the event that an AP does not start at 1, or sigma doesn't start at 1, all I want you all to do is to count it. Right? Count it. Take your time and try and count it out as best as you could. So this could be the sum of the first 20 terms is equal to, I'll use the first formula, 20 over 2 into 2a plus n minus 1 multiplied by d. Punch this in the calculator. How do you know whether it's an AP or not? Summation will always, well, I'll say 9 times out of 10, it will yield an AP. Remember, APs are as a result of continuous addition. And well, you'll check and see that you can actually test it and see, right? So just to be on the same, on the safe side, substitute your terms for about 4 terms and test it to see if it's an AP or if it is a GP. I will send all the paper ones on the classroom after this. Alright, so tell me if I answer your questions later. 20 over 2 is 10 into 2 to the 4 plus 19 by 3. $610. Or I can use S sub 20 is 20 over 2 into A plus, I'll work out what my last term is, there is 60. 60 minus 1 is 59. That is 59 and 2 is 61. And that is 10 into 61, which is 610. It can only be a AP or GP, not any time else. I don't understand that statement. It could only be AP or GP, not any time else. It could be either an AP or a GP, right? It takes for you all to know that, yo, this is actually an AP's question. I think that is why you're asking. This is actually an AP's question. I think the only way I can answer that is by practicing. You had to practice and see it. There will be, I'll post the link in this, or somebody just copy the link and send it across, not from the last video. Alright, next, number 4. A teacher illustrates APs by cutting a length of string into 10 pieces. So I have 10 pieces of string, which means I have 10 parts or 10 terms to deal with. The length of the pieces are in an arithmetic progression, and the entire length of the string is used up exactly. If the first piece, so again information, so I'm writing it down, T1 is 30 centimeters, and the fourth piece is 24 centimeters, calculate the total length of the string. Now, there is a trick in APs and a trick in GPs that you can use to calculate for unknown. The trick in the APs minus the terms in an AP. The trick in the GPs is divide the terms in a GP. And I'll show you what I mean probably a little afterwards. So I know that for an AP, T sub n is equal to A plus n minus 1 multiplied by D. Over here, they're asking us for the total length of the string. So I have T1 will be A plus 1 minus 1 by D. So T1 is actually A. So information. T4 is equal to A plus, A plus n minus 1 by D, which is A, T1 was 30. So this is going to be 30 plus 4 minus 1 is 3D. And 24 is equal to 30 plus 3D. Rearrange. 24 minus 30 is 3D, minus 6 is 3D, and D is minus 2. It's a little strange. If D is minus 2, they want to calculate the total length of the string, which is the sum of the first 10 pieces of the string, which is equal to n over 2 into 2a, same formula from above, plus n minus 1 by D. A little strange. This going to be, pull up a calculator. N over 2, which is 5 into 60, plus 10 minus 1 is 9. 9 multiplied by minus 2. Close bracket, close bracket. 210. So the sum of the first 10 pieces is 210 centimeters. The first term of our GP is 16. So one time A for the GP is 16 and the fifth term is 81. Given that the common ratio is positive, find the value of the fourth term. Alright, so T sub n is equal to AR to the n minus 1. So T5, which is 81, well, I'll go put the formula, is 16R to the 5 minus 1. 81 is 16R to the 4. 81 over 16 is R to the 4. I will fourth root both sides. Again, working is not necessary for all the paper ones, but it's good to put it there. So the fourth root of 81 over 16, this should be knowledge for you all, right? Plus or minus. The fourth root of 81 is 3. The fourth root of 16 is 2. It's plus or minus 3 over 2. They say that R is positive, so R is positive 3 over 2. Given that R is positive 3 over 2, T4 is equal to, well, we could just divide T5 by 3 over 2 to get T4. Let me do that now. We know that our T4 multiplied by R going to give me T5. So T4 is T5 over R, which is 81 divided by 3 over 2. 81 multiplied by 2/3. This into this is 27. 27 by 2 is 54. The next way I could calculate T4 is by using the formula AR to the n minus 1. The first four terms of a convergent GP is given by 81, 29, 9, 3. What is a convergent GP? The sum to infinity of this GP is, alright, so the sum to infinity only occurs if R is less than 1. S of infinity is A over 1 minus R. If the modulus of R is less than 1, A is 81 over, we could look at what R is right here. 81 over 20. Actually, let me do an easier way to calculate R. 9 over 3. No, this is last divided by the first, sorry, which is 1/3. 81 over 1/3 is 81 multiplied by 3, which is 243. Alright, 2 to the power 1. I see that in this question, so I'm changing everything to the same base one time. 2 to the power 1 by 4 is 2 squared. X plus 1. 16 is 2 to the power 4 to the power of 2x. First, let me hear what is a convergent. I'll tell you all what it is after this question. This is basis at, well, let me multiply it out. 2 to the power 2 into x plus 1. 2 to the power 8x. 2 to the power 1 plus 2 into x plus 1 is 2 to the 8x. Bases are the same, equate the powers. So I have 1 plus 2 into x plus 1 is 8x. Expand and solve. 2x plus 2. Well, I'm moving things around one time. 1 plus 2x plus 2 is 8x. I'll move the 2x. 1 and 2 is 3. 8 minus 2 is 6x. 3 over 6 is x. X is a half. Now, there are convergent and divergent progressions. You all need to know what a convergent progression is. You all don't need to know what a divergent, but I'll still tell you what. A GP could either get bigger and bigger and bigger and bigger, or it can get smaller and smaller and smaller and smaller, or it can oscillate, going from positive to negative, positive, negative. A convergent GP is a GP that gets smaller and smaller, and it actually converges towards a number. And in the case for number 6, this convergent GP converges to 243. Well, that is sum of all the terms when it converges. 243 will be the sum of all the terms. So convergent just means you're getting closer and closer and closer and closer to a number. Divergent means you're getting bigger and bigger and bigger and bigger and bigger and bigger. So for example, above here in the AP, if we were to say it have convergent and divergent arithmetic progressions, this will be a divergent arithmetic progression because we just keep getting bigger and bigger and bigger. And we're not convergent to any number at all. That's it. All the formulas on them are exactly the same thing for GPs. It's just a name for the convergence. That is it. The nth root of that, well, I seen I could simplify the underneath the root sign. So I'll have 2 multiplied by 2 squared to the power of m. The nth root of all that, this is 2 to the power 1 multiplied by 2 to the power 2m. The nth root of all that, that is the nth root of 2 to the power 1 plus 2m. I can change the nth root to be to the power 1 over n, 2 to the power 1 plus 2m, all to the power 1 over n, and base the power to power, multiply the powers, 2 to the power 1 plus 2m, all over n. We'll just write part D with the 2m first, and that's a-okay. Addition is commutative. Nice. Given that log of x to base 2 plus log of 6x plus 1 to base 2 is equal to 1, the value of x is, no, log's not on the understand mostly boy mean getting closer and closer to the number, not to the number, to a number. When you're converging, you're getting closer and closer, again smaller and smaller and smaller and smaller and smaller, and you're getting closer and closer to some number, the last term. Log of x to base 2 plus log of 6x plus 1 to base 2 are same bases here, so I'm gonna put this as log of 2 to base 2. Now the law says that if I have log of a to base b plus log of m to base b plus log of n to base b, the laws both ways. This is log of m n to base b. So I have that happening above here. So this could be log of x into 6x plus 1 to base 2 is log of 2 to base 2. I have the same log to the same base. It's a log equation, so I can remove log to base 2. X into 6x plus 1 is equal to 2. 6x squared plus x minus 2 is equal to 0. And Jesus Christ, I get a quadratic. Luckily, we will be allowed calculators, so I can go to my calculator and solve this quadratic. My calculator could solve it. Quadratic is maths. You all should be able to do that. Mode 2, A is 6, B is 1, C is minus 2. I get 0.5 as an answer and negative 0.66666 as an answer. That could be 2/3. So x is equal to a half or negative 2/3. Now, which one of these answers are going to be here? Because both of the answers are answers in the answers they give us. So which one is going to work? We have to check that back in our log equation. Generally, log of a to base b, a and b are greater than 0 all the time. If x is negative 2/3, I will get log of negative 2/3 to base 2 to exist. So x is a half only. What is the significance of that term? I really don't know. I'm gonna try and bullshit my way through that. Me know the significance of that term. We just know, all you have to know is calculate the sum to infinity of a GP. If there is a sum to infinity of a GP, then that GP is a convergence geometric progression. Alright, our next logs question. The value of this is, alright, so I can see that I can probably reduce everything. So let me see what we can do for this one here. Log of 8 is log of 2 cubed to base 4 minus log of 2 to base 4. Actually, I don't need to do that. Log of 8 minus log of 2 to base 4 plus log of 1 over 16 to base 4 is equal to, similar to this law above here, if I had a minus sign in between them, it would be log of m over n. So wherever I see the law, I'm going to apply the law. It could be 8 over 2. This could be log base 4. 8 over 2 multiplied by 1 over 16. You go with you 4. You go with you 4. This is log of a quarter to base 4. I can move the quarter and bring it to power of negative 1. Move the minus 1 in front. Minus 1 log 4 to base 4. Log 4 to base 4 is 1. So this is minus 1. We have time, pause for pause, we have time to do individual topics if you all want to in between. So if you all want a logs video, I'll make one video doing logs. If you all want a rationalization video, I'll do one video doing rationalization only. So it's all I had to let me know tonight. I'll take note of it and I'll see what I can do as long as I get the time. 1 plus root 3 over root 3 minus 1. We had to rationalize, but we have answers to work with. So what I going to do, I going to cheat. I going to work out what each of these terms are in my answers. I'm going to work out what this is and see what it is equal to from the answers. So 1 plus root 3 divided by root 3 minus 1. So this is 3.7320508088. And I'll write down the whole thing just to make sure. Well, I could rule out this, I could rule out this. Root 3 plus 2 easier to put on my calculator. Root 3 plus 2. Ah boy. So the answer is root 3 plus 2. I didn't even bother to touch rationalization. Alright, so I'll do one on logs, indices, and sets. That could take about 2 videos to make. Alright, nice topic, nice easy topic to do. Alright, I'll do it. By completing the square, f of x can be expressed as. Alright, now there are a couple ways to complete the square. There are 3 ways, and generally, if you all want, you all can learn these formulas. A is equal to A. H is equal to minus b over 2a. No, b over 2a. And C is equal to AH squared minus K. So it's just to plug it in the calculator. Yeah, you can do that for this one particularly, because I mean, to give you 4 answers. Why are you gonna fight up and rationalize it when I have 4 answers and one of them is correct? I can plug it in my calculator. However, if they gave us a variable somewhere inside of here, a different kettle of fish. We can't fight on that one, we had to rationalize it. Alright, so I want to express a quadratic in the form a into x plus h squared plus k, and a is minus 2, h is minus 8, and k is minus 5. And this is a nasty question, right? I try to remember it's minus b on 2a, you know. Let me just give that a quick check here, right? I'm trying to remember. I could be wrong. Bam 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 bam. Right, completing the square. Method 3. Nah, it's b over 2a, not minus b over 2a. Yeah. No, I was correct. Make me doubt myself, boy. He only boy. Alright. So in this case, a is minus 2. H is b. Shucks. B and C. What are you doing, boy? B is... Sorry, H is minus b over 2a. That is minus 8 over minus 4, which is 2. And C, K, is AH squared let me check this back again. I'll break aneurysm. C is AH squared plus K. Yeah, the correct one. AH squared plus K. So K is AH squared. C minus AH squared. Ah, there we go. Good. And K is equal to C minus A H squared minus 5 minus, well, that becomes a plus. 2 to the 4, 4 to the 8, 3. So my completed square is going to look like minus 2 into x plus 2 squared plus 3. Now, this to have a plus 3, this to have a plus 3 as my constant. These two have plus 3 as my constant, but is x plus 2 inside of the bracket, so the answer is C. So, 3 formulas you all can just learn off, not that one. You all can just learn this off if you have to complete a square. Cool? You all can just learn it off. Shane. Where's the scene? The roots of the equation are, there's a discriminant, b squared, oh good lord. B squared minus 4ac. B is minus 1 squared minus 4ac. That is 1 minus 8 is less than 0. So the roots are, that we see, not real and distinct. Shane, how was your exams, son? Were they good? Were they bad? For that, the maximum value of what? Okay. The maximum value of that and the value of x for which that is a maximum are respectively. So a maximum value for a completed square, if I have something in the form a into x plus h squared plus k, the maximum or the minimum point is going to be coordinates minus h comma k. The maximum or the minimum value of the function is going to be k, and the value of x for the max or min is going to be minus h. So in this one here, the maximum value of the entire function will be k, which will be 4. So it's either c or d. And the maximum value of x for which this occurs at is minus h, which is going to be minus 1. So the answer is C. Just paper ones. Mash up, man. Mash up. I'm expecting good things from you, Shane. Real good things. F of x is equal to that. Given that f is 1 to 1, the value of k is f of x is 1 to 1. Oh, for x is greater than or equal to k. All right. So we have x into x plus 5 plus 6. I'm going to expand. X squared plus 5x plus 6 is f of x. No, I don't think no teachers could explain this as good as me. We're only talking about one-to-one functions. One-to-one functions occur. We know one-to-one functions are one element in the domain is mapped onto one element in the codomain. But on our graph, what does that mean? If I have y is equal to x, simple straight line, the numbers on my x-axis are elements of my domain. The numbers on my y-axis are elements of my range or codomain. If f of x is 1 to 1, then for every one element here, when we go up, meet the graph, go across, we are mapped onto one and only one element here. So 2, 2, 3, 3, 4, 4, and so on. Compare that to a curve. For every one element here, yes, I am mapped onto 1, but minus 1 is also mapped onto 1, which means many elements or more than one element in my domain is mapped onto one element in my codomain. Minus 2 and 2 both map on to 4. So this is why we have many to one relations, which are functions. The question here states that this particular graph is 1 to 1, but for a certain piece of the graph. So if I look at this one here, I can say it's 1 to 1 if only this piece of the graph exists. I'm going to just do a little rubbing off. If this piece of the graph never ever existed in life, then I can say that this red piece here is 1 to 1, because I have, all right, nothing else is mapping onto 1. Nothing else is mapping onto 4. Now all these here are valid points to use as well, but just using the easy points. Here, nothing else mapping onto 9. So whenever x is greater than 0, well, you could put greater than or equal to 0. Whenever x is greater than or equal to 0, this part of the graph is 1 to 1. But for all these values here, it's many to 1. So this question asks us, well, which part is this graph 1 to 1? Now you can do a couple things. You can, if you're good with your calculus, you can go ahead and differentiate this, calculate the coordinates of the minimum or the maximum point, and state, well, you know, when x is greater than the x value in my minimum or maximum point, well, that will be the the values of x for which this function is 1 to 1. It could be less or more, but the question states greater than or equal to. Another way is you can completely square using the tips I gave you all above. And completely square, get the coordinate of the minimum point. This will be a minimum point. Get the coordinate of the minimum point and state, well, x had to be greater than or equal to that. Well, the easiest thing to do here is differentiation. F dash x is 2x plus 5. Let that equal to 0. And solve for x. X is minus 5 over 2. This here is the minimum point. Now remember, I'll draw the graph now. We have the answer. X will be greater than or equal to minus 5 over 2. Here. I'm going to draw this graph. X into x plus 5 plus 6. X into x, good lord. X plus 5. Close bracket plus 6. Now look at this here. Similar to this red graph, but the blue graph now has different points for which it will be 1 to 1. Now this is 1 to 1, everything greater than or equal to 0, or everything less than or equal to 0. Greater than will only consider this part of the graph alone. Less than will consider this part of the graph alone. But in the blue graph now, this here is negative 5, 1, 2. So from here onwards, my graph is 1 to 1, or from here backwards, my graph is 1 to 1. Range and domain and stuff is something that takes a while for you all getting used to. Well, for those boys who were with me, they could probably attest to really understanding what range and domain means on a graph. A function f is defined by f is such that x is mapped onto, this is just a fancy way of saying f of x is equal to x plus 3 over x minus 1. X is not equal to 1. F inverse of minus 4 is equal to, is there an easy way to do this one? There is. There actually is. Alright, so let me do a little bit of teaching again. I don't mind teaching when we're doing solutions, right? All I mind teaching when we're doing solutions, let me know. Alright, so generally, if I'm going from here to here, I'm using f of x. And if I'm going from here back to here, I'm using f inverse of x. So if I have 3 plugged into f of x gives me 9. When I plug in 9 into f inverse of x, I get back 3. So in this fella here, f inverse of minus 4, let me say that out. F inverse of minus 4 will give us something. Let me call it a. So f of a will be equal to minus 4. So I'll check and see. F of a is equal to minus 4. What will give a minus 4 there? Well, x plus 3, a plus 3 over a minus 1 is minus 4. Cross multiply. A plus 3 is minus 4 into a minus 1. A plus 3 is minus 4a plus 4. Move it across, we get 5a is equal to, move it across, we get 4 minus 3 is 1. And a is 1/5. So f inverse of minus 4 is a, which is 1/5. You can do that. That is if you understand functions properly. Or you can actually go and calculate your inverse function and then calculate f inverse of minus 4. You'll get the same thing. You'll get 1/5. A function g is defined by, again, g of x is 3x minus 1. Expressed in terms of a, g of 3a minus 1, So g of 3a minus 1, I just replace in x with 3a minus 1. That is 3a minus 1 minus 1. 9a minus 3 minus 1, 9a minus 4. Part D. Teaching is good? Okay, good. At least one person learning something. If you have any in-depth questions, anything on any topic with teaching, just let me know in the comments, right guys? Just let me know. Functions f and g are defined by, again, f of x is 3x minus 2 and g of x is 12 over x minus 4. The composite function fg, so fg of x, this could be f of 12 over x minus 4, which is 3 into 12 over x minus 4 minus 2. You can't get away from this one. You had to know your algebra to do this one. I showed you all the shortcut to simplify this bracket here. There's 12 minus 4x over x minus 2. They want it as a fraction minus. Okay, cool. So we have 3. Actually, if they want it like that, we don't even have to simplify this here. 12 over x minus 4. That could be 36 over x minus 12 minus 2. 36 over x minus 14. B. I do in French at the moment, but I still have the stream on the side. You could always go ahead and watch the stream afterwards. That is no problem. The range of values of x for which, okay, have a nice little trick I can show you all with this now. When you're calculating range of values, generally, two things can happen. Above the line will always be greater than 0. Below the line will be less than 0. Right? The equal to sign is also catered for inside of here, right? So we have two different graphs we're going to be dealing with. Greater than or equal to, or less than or equal to 0. I can have two types of graphs. I can have a maximum or a minimum graph, right? Well, minimum or maximum in this case. Generally, when you're calculating solutions on a graph, they lie in particular places. Solutions for this, the top graph, could lie here or here combined with here. Never in the middle and never on the outskirts. So it's never here and it's never here or here. Same thing applies for the bottom graph. Solutions can either lie here or use a different color, or they can lie here combined with here. So if it's in the middle, if it's in the middle, let me say this point is A and this point is B. This point is A and this point is B. You will have to solve the quadratic inequality, which is just like a regular quadratic equation. The green solutions are going to be given by A is less than or equal to X, which is less than or equal to B. The orange solutions are going to be given as, and this is important, X is such that X is less than or equal to A, union X is such that X is greater than or equal to B. Can't say for the live, sir, but we'll show watch it later. Bless I, bless Amal. In the bottom graph, A could be less than or equal to X, could be less than or equal to B. And the green outskirts, same thing like above. X is such that X is less than or equal to A, union X is such that X is greater than or equal to B. I'm going to apply that to this particular graph here. Now, for this inequality, it's easy for me to solve it, right? Don't do this in paper 2, please. Right? Warning, do not do this in paper 2. I'll put the numerator equal to 0. Solve. Put the denominator equal to 0. So these are my solutions. Sorry, equal to 0. These are my solutions. So it come like A now is V minus 1 and B is V 3 over 2. So we want to know whether this graph is greater than 0. So this now will be a smiley face. It will be a positive x squared. So where is it greater than 0? If A is minus 1 and B is 3 over 2, it's greater than 0 for the orange part of the solutions. Alright? This sign will dictate what sign goes here and what sign goes here. If it's a greater than sign in the question, you wouldn't have no greater than or equal to's in your solution. Alright? Don't bother with the direction, just bother with the need here. It's either it's greater than or equal to, you have the equal to sign there, or you don't have the equal to sign there. Alright? So my solution, I are watching my options they give me. My solution is going to be x is such that x is going to be less than minus 1. Union x is such that x is going to be greater than 3 over 2, which is part C. Right? Now, again, if the question just had a little equal to sign here, then brother man, I'm going to attach the equal to sign in my answers. Coordinates of the point that and that the perpendicular bisector to the line AB is given by the equation. How do we working? A is 2 minus 3. B is minus 10 minus 5. X1, Y1, X2 and Y2. Gradient Y2 minus Y1 over X2 minus X1. Minus 5 plus 3 is minus 2 over minus 12, which is equal to 1 over 6. The perpendicular bisector will have a gradient of minus 6. So I'm looking to see which one of these lines here gives me a gradient of minus 6. I'm doing that check first. So I wouldn't get a gradient of minus 6 if I rearrange this. If I rearrange this, I will get a gradient of minus 6. If I rearrange this, I will get a gradient of minus 6. So I have no choice but to actually go and calculate the value of the constant C in the equation. So it is the perpendicular bisector we're looking for, right? Yes, it is. I'll have to find the midpoint of AB. So the midpoint of AB is going to be x1 plus x2 over 2, y1 plus y2 over 2. This is going to be 2 minus 10 is minus 8 over 2 is minus 4. Minus 3 plus 5, minus 3 minus 5 is minus 8 over 2, which is minus 4. So that's my perpendicular bisector I'll be using in the equation of the line. So y minus y1 is equal to m into x minus x1. This is a nice question. So y plus 4 is equal to minus 6x minus minus, I'll grab minus 24. Bring the minus 4 across, I get y is equal to minus 6x minus 28. I rearrange everything, send everything on the left. I get y plus 6x plus 28 is equal to 0. B is the answer. The lines 2x that intersect at the point P, where P is equal to All right, so this one you can do one of two things. You can actually substitute each value of p into the equation, or use simultaneous equations. I'm gonna use the simultaneous equations because it will be a little bit easier, because A, B, C, and D, it's easy to mix up their minus signs when you're plugging it into the questions. So I'll say this is 1, this is 2. In my mind, from 1, y is equal to, move them two things across, minus x minus 1. Substitute y into 2, minus x minus 1, minus 3x minus 13, minus 2x minus 2, minus 3x minus 13 is equal to 0, minus 5x minus 15 is equal to 0, minus 5x is equal to 15, and x is minus 3. So it could be either C or D. When x is minus 3, y is minus x minus 1, which is 3 minus 1, which is positive 2. The answer is D. Right, so we'll just do one paper tonight, right? The radius r and coordinates of the center C of the circle with equation that are, all right, so x squared minus 2fx plus y squared minus 2gy plus c is equal to 0 is the equation for a circle, where fg is the center. So I have here x squared minus 6x plus y squared plus 4y minus 12 is equal to 0. I'm going to bring it in this particular form up here. X squared minus 2 something x plus y squared minus 2 something y minus 12 is 0. 3 must go here for me to get back the minus 6. Minus 2 must go here to get back the positive 4. FG is the center, which will be 3 minus 2. 3 minus 2. This is the only one with 3 minus 2 as a center. So that's my answer. Number 24. The length of the vector P is root 13 and K is real. Okay, the length of a vector is going to be the square root of the I component squared plus the J component squared minus K squared is root 13. So 2 to the 4 plus K squared is equal to 13. K squared is equal to 13 minus 4, which is 9. K is the square root of 9, which is plus or minus 3. 1 and 2 only. 1 or 2 only, sorry. Yeah. That was a nice question. The value of the real number t for which the two vectors are parallel is, so if they're parallel, they are scalar multiples of each other. A is 4i plus tj, and B 2i minus 3j. I like to show let A be equal to lambda B. So 4i plus tj is equal to lambda into 2i minus 3j. 4i plus tj is 2 lambda I minus 3 lambda j. Equate the i's. 4 is equal to 2 lambda and lambda is equal to 2. Equate the j's. T is equal to minus 3 lambda. Lambda is 2 minus 3 into 2. T is minus 6. Right? I like to do that. You can see it as well. You can clearly see it here. I have to multiply B by 2 to get that A component. Well, before I had to multiply 2 by 2 to get 4. I got to multiply 3 by 2 to get T. Alright, the position vectors of A and B relative to an origin are 2, 3, and 7 for respectively. The acute angle AOB is given by A dot B is mod A, mod B, cosine theta. A dot B, I'll dot these two here, multiply them by each other, which is 14. And I'll add them to the product of these two, which is 14 and 12. The size of the first vector is going to be 2 to the 4. And 4 plus 9 is 13, root 13. 49 plus 16 is 5 and 1 is 6. 65 root 65 cosine theta. Theta is cosine inverse. 14 and 12 is 4, 5, 6, 26. 26 over root 13 root 65 B. This question repeats a lot. Everybody good so far? Question for those who hear. Do you all prefer the lives, or would you all prefer me to do a video just doing the solutions? Let me know. I go in here, I go in here, and I go in here. 1 plus sine x squared plus cosine x squared all over 1 plus sine x by cosine x. 1 plus 2 sine x plus sine squared x plus cos squared x. This is going to be 1, and this is all over cosine x into 1. I believe the 1 plus sine x, because I think something gonna happen. So it's gonna be, this whole thing here is 1. 1 plus 1 is 2. So I get 2 plus 2 sine x over cos x into 1 plus sine x. This could factorize 2 into 1 plus sine x over cos x into 1 plus sine x. You cancel with you, and we get 2 over cos x. Questions similar to this come a lot, right? They come quite a lot, right? So the USC basketball finals, game 3 starting just now. But I know it's tied 1-1. I don't really follow basketball, but a lot of my friends, they favor the it's the Celtics, and I think, right? So lives, okay, I see a couple of people say the lives, right? No problem. That is equal to double angle formula, compound angle formula, sorry. Cos of A minus B is cos A cos B plus sine A sine B. Take away cos of A plus B is cos A cos B minus sine A sine B. When I expand the brackets, I get minus cos A cos B plus sine A sine B. So cos A cos B goes over the cos A cos B, and I get 2 sine A sine B, which is A. I'd like to worry is either I want the Celtics to win. I don't really follow basketball, so I can't help it. Sine theta is 15 over 17, and theta is obtuse. Right, no scene. Bam, bam, bam. Sine of theta is opposite over hypotenuse. We can use Pythagoras Theorem to calculate the adjacent. 17 squared is 15 squared plus, we could call it x squared. 17 by 17 is 17 squared minus 15 squared is 64. Root 64 is 8. So x is equal to 8. Cos theta is equal to adjacent over hypotenuse, and let's say theta is obtuse. An obtuse angle is in quadrant 2, so this will be negative. Minus 8 on 17. The smallest positive angle for which sine theta plus cos theta is equal to 0 is, just check all of the angles, man. Change your calculator to radians and check all the angles. Don't bother to do no calculations there. Radian measure sine of pi on 4 plus cosine of pi on 4 is not 0. So these fractions are increasing going up period. So they're looking for the smallest positive angle. So I check in the smallest going to the biggest. Sine of 3 pi divided by 4 plus cosine of 3 pi divided by 4 is 0. You get answer. The working for this one, sine theta plus cos theta is equal to 0. Sine theta is minus cos theta. Divide both sides by minus cosine theta. Or you could divide both sides by cosine theta. I'll get tan theta is minus 1. And you can calculate when tan theta is minus 1, solutions are going to lie in 2 and 4. So in quadrant 2, it will be 180 minus the principal value, which will be 45 degrees, which is 135, which translates to 3 pi on 4. Go and watch the trigonometry video to understand what I just now did there, if you want. For those who are interested in doing the pure, the trigs video that I made covers a lot of things. I wouldn't say a lot, but it sets a very, very strong foundation for pure maths. For that, the solutions will lie in all quadrants in a question like this, because I will have sine squared theta is equal to a quarter, and the square root sine theta will be plus or minus the square root of a quarter, which is plus or minus a half. Solutions are going to lie in all quadrants because sine is both positive and negative here. That is equal to compound angle formula again. 2 sine of x minus pi on 2 is sine x cosine pi on 2 minus cosine x sine pi on 2. Which one will give me 0? Sine pi on 2 will give me 0. So this whole thing will turn out to be 0. Cosine of pi on 2. No, sine of pi on 2 is 1. Sorry. This will give me 0. So this will be minus 2 cosine x. Because sine pi on 2 is 1. Minus 2 cosine x. Which of the following range of values is f of x equal to 2 plus, okay, so your range is here, like I said in the graphs. Go back in the video and check it out. The range is with respect to your y-axis or your vertical axis. In this case here, my amplitude for this graph is going to be 1. Right? So this is going to be my cosine curve here. Don't matter cosine 3x, it don't matter these things here. I'm focusing on this here. So generally, this is between 1 and minus 1. This 2 means I'm shifting the whole graph up 2 units. So from 1, we go 2 to 3. From minus 1, we go 0 to 1. So 3 and 1 will be my my range of values for the graph. So A is my answer. The values of x which satisfy this particular equation are, alright, I don't want to solve this. Substitute values, but substitute values in a smart way. Let's think about it. If I substitute pi on 6, wait, alright, in this case here, I thought both of them were positive pi on 6. Alright, If I substitute 7 pi on 6, then the answer could either be C or D. I still have to go and substitute another value. If I substitute 5 pi on 6, my answer could either be A or D. I have to check now. I have to make another substitution. However, if I substitute 11 pi on 6 and I get the answer equal to 0, then the answer is C. If I substitute pi on 6 and I get the answer equal to 0, then the answer is A. So let's first check pi on 6. 2 cosine pi on 6 squared plus 3 sine pi on 6. That's not the answer. So I can rule out pi on 6 as a solution. Now, 5 pi on 6 could still be a valid solution. Alright, it could be a valid solution. Next, I will try. Let's try 11 pi on 6 now. 11 pi on 6. 11 pi on 6. Error. Sine. Something error. Oh. 2 cosine 11 pi over 6 squared plus 3 sine 11 pi over 6. Not the answer. So 11 pi on 6 is not the answer. Right, so we gotta check again. Let me check in minus pi on 6. 2 cosine open bracket minus pi on 6 close bracket open bracket close bracket squared plus 3 sine of what again minus pi on 6 open bracket minus pi on 6 close bracket. Okay, so minus pi on 6 is a solution, so B is my answer. So number 28 was compound angle formula 2. Let me go back. Yes, 28 was compound angle formula, and the working for 28 is right here. Right, the first piece here, the first piece is cosine of A minus B. The second piece is minus cosine of A plus B. What I did, go back in the video and you'll see, I put the brackets and then I use the minus sign and I expanded the brackets, okay? Number 35, a simple differentiation. We did calculus. dy dx is 3 into 3x minus 2 squared multiplied by the differential of the brackets, multiply the 3 by the 3, and I get 9, and the only thing with 9 is the first one. Next, dy dx is equal to, alright, is of the form u and v du dx minus u dv dx all over v squared. I don't have to bother because all over v squareds here, all of them are the same thing. So I just focus on my numerator. 2x minus 11 multiplied by 3. Alright, I've seen one here. Nice. Minus 3x plus 5 multiplied by 2. C is my answer. Bob's your uncle. The curve C is given by the equation that the value of dy dx at the point where x is pi on 3 is, well, let me differentiate. When I differentiate sine, I get negative, I get cosine, so this is 3 cosine x. When x is pi on 3, I get 3 cosine pi on 3. Plug it in my calculator. 3 cosine open bracket pi on 3 close bracket 1.5 or 302. B. The point P, 2, 2, lies on the curve with the equation x into x minus 3 all squared. The equation of the normal to the curve at the point P is given by, so let me get dy dx. Actually, a question like this came for the AddMaths exam this year. Something to differentiate, something similar. Yeah, something similar to this, I think. Some of you would have used the product rule. As a man, would I expand this? X into x squared minus 6x plus 9 x cubed minus 6x squared plus 9x dy dx is 3x squared minus 12x plus 9. The equation of the normal at the point P. Alright, so again, the equation of the tangent at P when x is equal to 2, dy dx 3 into 2 squared minus 12 into 2 plus 9. 2 to the 4, 4 to the 12, 24 plus 9. 12 minus 24 minus 3. The equation of the normal is going to be a third. I'm sorry, the gradient of the normal is going to be a third. And at P, let me calculate it. Y minus y1 is m into x minus x1. So y minus 2 is equal to a third into x minus 2. 1/3 into x minus 2. See. And for number 37, you have to add 2. No, I differentiate the sine x, and when I differentiate 2, it turns to 0. When we differentiate a constant, it turns to 0. The curve C is given by equation. The second derivative is given by, alright, so we have y is 4x plus 9x to the minus 1. Differentiated once, I get 4 plus minus 9x to the minus 2. Differentiate again, I will get plus 18x to the minus 3. For the x to the minus 3 on the denominator, I get 18 over x cubed. The positive value of z for which that is equal to 9 is, alright, so when I integrate that, I get x cubed over 3 evaluated at z and 0 is actually equal to 9. I will get z cubed over 3 is equal to 9, because when I substitute 0, this turns to 0. Z cubed is equal to 27, and z is equal to plus, no, yeah, 3. That's 3, not plus or minus. That's okay, Ismail. Let us happen. That's why I come out here for. The gradient of the tangent to the curve at C is given by that. So that is dy dx. The curve passes through the point P. The equation of the curve is given by that. Jesus Christ. This is a bacchanal question for a multiple choice. Now, one thing I would have probably done is I would have taken A, B, C, D, and I would have differentiate each one of them using the shortcut to the chain rule. And see if I get dy dx. That is what I would have do. Because if I work this out the traditional way, I'll have to integrate, calculate my constant C, and then I go get the equation on my line. But I'm going to differentiate each one of these things here. So the first one going to be 2 into 3x plus 4 to the minus 1. When I differentiate this, I will get minus 2. I'll try and take it back this, right? So when I differentiate this, I'm going to get the minus 2 on the top. I have that. So which one of these things, when I differentiate it, I'll get 1 on top? Could be this or this. Could be because of the 3 inside, the 3 outside here, right? I think this answer is C, right? So watch. I'm going to differentiate C. I'll get minus 2 over 3 into 3x plus 4 to the minus 1. Differentiate and multiply by the power. I get 2 over 3 into 3x plus 4 minus 1 from the power, and I multiply by the differential at the brackets. This 3 cancels with this 3, and I get 2 over that. So C is not the answer. So I rub it off. C is not the answer. I'm going to differentiate 1. I get minus 1 over 3 into 3x plus 4 to the power minus 1. This one looking like the answer. I get 1/3 3x plus 4 to the minus 2 multiplied by 3. You cancel with you, and I get 1 over 3x plus 4 squared. So the answer is B. Yes, Johan, it looks like a paper 2 question, but there are ways you can work your way around it, because they actually give you all the answers to these questions, guys. The answer is either A, B, C, or D. All right, let's go with number 42. The finite region R is bounded by the y-axis, the x-axis, and the arc of the curve that. Okay, so they actually define R. The area of the figure in square units is, it will be the integral of x minus 3 squared with respect to x between the limits 3 and 0. I'm going to expand this to make life easy. Integral between 3 and 0 of x squared minus 6x plus 9 dx. X cubed over 3 minus 6x squared over 2 plus 9x evaluated between 3 and 0. Plugging in 3 cubed over 3 minus, bam bam, 3 into 3 squared plus 9 into 3. When I plug in 0, I get 0. 27 over 3 is 9 minus 9 3s are 27 plus 27. You cancel with you, I get 9. What is it plus? What is it plus and plus 4 good lord, and 41? What do you mean the plus and the plus 4? I understand what you're asking, man. I really understand what you're asking, man. If you want, you could try and differentiate each one of these things here using the long way, and that might answer your question. I understand what you're asking, man. What do you mean this 4? When I differentiate this 4 here and this plus 1 here, I get 0. If that is what you're asking, man. The finite region enclosed by the curve, right, is completely rotated about the volume generated when it's rotated about the x-axis could be the integral of pi y squared dx, and it could be between the limits 3 and 0. Y is equal to x, so y squared will be equal to x. So this will be equal to the integral between 3 and 0 of pi x dx, or pi the integral of 0 b in ABC. I'm going back again, Ismail. 41 in ABC, the plus 1 and that's just a separate term. That will be the constant of integration, right? That will be the value of c when you integrate. But that's just a separate term. Hey, we done? Oh no, 44. That is equal to, all right. We could do the shortcut here as well. This is going to be 2x plus 3 to the power 6 over 6 multiplied by 2, which is 2x plus 3 to the 6 over 12 plus c. 12. Last one. Definite integral give. Okay, this is a nice last question. Whenever I have sine and cosine to integrate, I just write the differential of them first. Y sine x dy dx is cosine x. Y is cosine x. Dy dx is sine x with a minus sign in front. When I integrate cos, I get sine. When I integrate sine, I get negative cos. So when I integrate sine, I'm going to get negative cos. So that is minus 3 cosine of x. Take away. When I integrate cosine, I get sine. Minus 2 sine x plus c. Minus 3 cos x minus 2 sine x plus c. C is the answer. Alright, let me just go and change this Dr. questions. I just changing the title in the meantime. Let me change this title real quick. Specimen paper. Good. Cool. Yeah. Questions. Any questions? Are there no questions? Like the video, share it. We're on the road to 1,000 subscribers, guys. Let me see if we can get the 1,000 subscribers. My thoughts on paper 2. Lick up. Like, it was so easy. Barring some questions that made you think. Definite distinction. Some of my students are going to merit in it, so lick up thing. Hopefully next year comes just as easy. Hopefully. Fingers crossed. Alright guys, well, we take a little while to finish out the paper. As we continue doing the papers, we will reduce the amount of time we will take completing a paper, because it will be less teaching and actual working in the questions. One a day up to the paper 2. Night before paper 2, we'll come on, do some questions, do some work, and yeah, that's it. So if you guys are okay, you will go see me in our time. Right, so that is so out, over and out. Tell me how you really feel, 'cause I don't mind.